turn long reports into crisp, one-sentence summaries. By the end, you will have 5 simple summarizers. You will see how each step improves quality and why some are faster. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced in simple Python. Long documents break tools. People want a single clear takeaway from a report or a research paper. Success looks like a short, faithful sentence that captures the main point. The pain is that models have context limits and compute costs. A naive call to a large model on an entire report can be slow or truncated. Building progressive, sheet baselines helps you decide when to use a full LLM and when a lightweight heuristic is enough. The intuitive idea is to start simple and add complexity only when needed. First, pick the lead sentence for a short document. Then try a greedy budgeted pick. Next, use token frequency to rank sentences. If the text is long, split it into chunks and summarize each. Finally, reduce chunk summaries into one ranked sentence as a baseline. Imagine a quarterly product report with many headings. We use the same report throughout to compare each method side by side. We will build 5 progressively stronger summaries and end with a single ranked sentence that summarizes a long report. First, we extract a quick lead sentence. This snippet extracts a lead sentence summary from a short document. It assumes the first sentence often contains the main point, so it tokenizes the text into sentences and returns the initial sentence as the summary. This approach is extremely fast and cheap. It works well on editorial style reports, where writers lead with a conclusion. The main adjustable choice is how many lead sentences to return. Increasing that number gives more context, but costs more reading and can weaken brevity. Use this as a baseline to set expectations before using heavier methods. Next, we apply a simple, greedy budgeted selection. This example composes a summary under a word budget using a greedy pick. This snippet builds a summary by greedily selecting sentences until a fixed word budget is reached. It scores sentences by a simple importance measure and then adds the highest scoring sentences one by one until the budget hits the limit. The key parameter is the word budget, which directly controls brevity and coverage. A tighter budget forces stricter choices and favors high-value sentences. A looser budget produces more complete summaries, but reduces concision. This method balances readability and length without invoking deep semantic models. Now we rank sentences by token importance. This code ranks sentences by token frequency to select salient content. This snippet computes token frequency across the document and scores each sentence by the sum of its token frequencies. It then selects top-ranked sentences as the summary. The intuition is that repeated tokens often mark topic words. This method highlights salient phrases and is robust on domain-specific reports where key terms repeat. Adjustable choices include the token vocabulary size and whether to use raw counts or inverse weighting. Increasing vocabulary size captures rarer signals but risks noise. Adding inverse weighting reduces the impact of very common terms. Next, we deal with truly long documents by chunking. This snippet chunks a long document and summarizes each part by its lead. This example splits a long report into overlapping chunks, sized to fit context limits, and then extracts the lead sentence from each chunk. The goal is to preserve local context so each section yields a focused mini-summary. The main parameters are chunk size and overlap. Larger chunks reduce the number of chunks but can dilute local focus. More overlap preserves continuity at extra cost. This approach is practical when a full document cannot be processed at once, and when you want per-section takeaways before reduction. Finally, we reduce the multiple chunk summaries into one ranked line. This snippet reduces chunk summaries into one ranked sentence as a baseline. This example treats chunk summaries as a small corpus and ranks those sentences by simple signals like length, adjusted importance, or token reuse. It then selects the top-ranked sentence to present as the overall summary. The adjustable parameter is how many chunk summaries to consider or whether to re-weight by chunk position. Using more candidate summaries can improve recall, but may introduce redundancy. This reduction gives a single, cheap baseline that often matches user needs and reveals whether you should call a more expensive LLM for refinement. Recap: this is a progression from a single lead sentence to a chunked reduction. Use the simple lead when writing style is clear, use greedy or token frequency for constrained budgets, and chunk when the text exceeds context limits. One caveat is that these heuristics can miss subtle inferences that a full LLM would catch. Next step, tune the chunk size and overlap to balance summary quality and latency for your report type. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.